Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Azim bin Fauzi. So today I would like to demonstrate on how to simulate the fast Fourier circuit analysis to find the output of fast Fourier transform in Simulink MATLAB. So this is the circuit design by our group, which based on our schematic circuit earlier. So I will elaborate on what is the component in this Simulink MATLAB. So the first one is the pulse generator. The pulse generator, where it produces a square wave for the circuit, and then it's connected to the voltage source. From the voltage source, it's connected in series with the resistor, which is the first load, and then connected in parallel with the inductor and capacitor, and then connected also in parallel with the resistor and the inductor. So the purpose of this simulation is to find the output graph of every branch, which is the voltage and circuit. So let's see the first load. The first load is so when we want to find the voltage, we must connect it in parallel. So this is the voltmeter. We connected the load in parallel with the voltmeter. So this is the load connected with this voltage measurement, and this is the FFT block, or known as the fast Fourier transform, and then connected to the voltmeter scope. So here from the scope we can see the graph output for the voltage here, and then same goes to the voltage here. This is the load, and then we connected it in parallel, and this is the voltage measurement, and also this is the FFT block and connected to the voltmeter scope. And also same goes to here, which is the last one. This is the load connected in parallel with the voltage measurement, and then to the FFT block and the voltmeter. Okay, then after finish find the voltage, we must find the current branch. So this is the I total, this is I1, this is I2. So for KCL, I total is equal to I1 plus I2. So here is the ammeter. So to connect the ammeter, we must connect the ammeter in series with the circuit. So here's the circuit, and this is the current measurement, and then connected in series with the FFT and also the ammeter. So we can find the output graph here. And same goes to the I1 and I2. Connect the current measurement, FFT, and also the ammeter block. Same goes with here. Current measurement, FFT, and also the ammeter block. And the last one is we must find the average power of this circuit. So as we know that power is equal to IV, so we just connected the current here and the voltage here, connected with this is the product or the multiplication process. So we just have to multiply these two value, and then we will get the wattmeter, the output graph here. This is the output from FFT, so we don't have to put FFT here since it's already in FFT form. And then let's see the simulation. Alright, let's test the simulation. It takes quite some time. It's now compiling, and then okay, done. Okay, now let's see the voltage first. So here's the output voltage. This is the output graph, FFT graph, and then this is the second voltage here. This is the output graph, and then the last one is here. Yes, as we can see here, this is the parallel circuit, so we know that voltage here is the same as voltage here, which is the V1 is equal to V2. And then we can see the current here. This is the I total. I total here is the current in. And then second one is there, is I1. This is the graph output of I1. And then the last one is here, I2. And this is the graph output of I2. Okay, then for the last one, which is wattmeter, to find the power, here is the wattmeter scope. Okay, this is the wattmeter output. and then we will compare with the manual calculation. So yeah, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad Afandi bin Muhammad Khusrin. My metric number is BE20203. I will explain about the comparison between manual and simulation answer. For the first one is I total. We calculate the I total using the Ohm's law, which is Vs over Zt, and we found the answer like this. And we run the answer in simulation, which is MATLAB software, and get this graph. Okay, next, the I1 current. So to calculate the I1 current, we use the Ohm's law and we get this answer. After that, we substitute the n with the 1. So the final answer we will get is 0.35 plus J0.23 or 0.4, and the angle is 33.3. So after we run the answer in the MATLAB simulation, so we will get this graph. Next is I2 current. We also use Ohm's law formula to calculate the I2, where VO over Z1. So the answer we will get like this. Then we substitute the n with 1 and we will get the 0.1, and the angle is negative 95 degree. So we run this answer in MATLAB and we get this answer, this graph. For the voltage one, V1, so we use the this formula and we substitute the n with 1, so we will get the answer like this. So we basically V1 and V2 is the same value because the both of voltage has in a parallel circuit. So after we run the answer in the MATLAB simulation, we will get this answer. Same with voltage 2. So the answer we will get the same. For the last but not least, for the average power, we use the general equation for the P average. So we substitute all the value in the equation and we calculate the value of the P average, which is 0.25 watts. So we run it in the MATLAB simulation, so we will get this graph. That's all from me. Thank you.